Welcome. I'm Rashmi Shah, your instructor to this comprehensive training video on Snowflake Cortex and large language models.
Welcome to this comprehensive training video on Snowflake Cortex and large language models. We will explore how Snowflake integrates cutting-edge AI directly into your data workflows, ensuring security and scale. Let's get started with the foundational concepts. Snowflake Cortex is Snowflake's comprehensive suite of artificial intelligence features. It is specifically designed to integrate large language models, or LLMs, directly into your data workflows within the Snowflake Data Cloud. The main goal of Cortex is to help you easily understand and analyze unstructured data, answer free-form questions, and get intelligent assistance, all without moving your valuable data out of the platform. Key capabilities within the Cortex suite include Cortex AI functions for quick tasks, Cortex agents for complex orchestration, Cortex search for finding relevant documents, Cortex analyst for structured data queries, and Document AI for processing PDFs and images. A major advantage of using Cortex is that Snowflake fully hosts and manages all the underlying AI models. This setup ensures superior performance, high scalability, and robust governance, keeping all your sensitive data securely within your Snowflake environment. Cortex provides access to cutting-edge, industry-leading LLMs from multiple major providers such as Anthropic, Mistral AI, and Meta, along with Snowflake's own models. You can access Cortex features seamlessly using standard interfaces like SQL functions, Python APIs, especially through Snowpark, and dedicated REST API endpoints, allowing for easy integration into any application. This diagram shows the main features integrated within Snowflake Cortex. At its heart, Cortex uses dedicated AI functions powered by large language models for tasks like summarization and translation. For deeper insights, Cortex analysts handle structured data, while Cortex search deals with unstructured data like documents. Cortex agents orchestrate these different capabilities, intelligently combining results from both structured data via Cortex Analyst and unstructured data via Cortex Search, as well as accessing the core AI functions. Document AI specializes in preparing documents for use within Cortex. All these interconnected components work together to deliver comprehensive intelligent assistance, ultimately providing you with actionable insights and accurate answers, all built securely within Snowflake. This integrated system ensures that whether your data is structured in tables or unstructured in documents, Cortex can leverage AI effectively. Building upon the introduction, let's explore Cortex AI functions, which are purpose-built and fully managed large language model features. These functions are designed to automate routine, yet complex, analytical tasks instantly, meaning you can start using them right away without needing to customize or train any underlying models. These powerful functions allow you to perform deep unstructured analytics on various data types, including raw text and even images, by integrating their calls directly into your standard SQL queries or Python scripts. The core functions available in Cortex cover essential LLM operations. They perform text completion for generating responses, summarize long documents quickly, translate multilingual content, and extract specific answers buried within large amounts of unstructured data. For instance, the complete function takes a prompt and returns a generative response, while the translate function can seamlessly convert text from one supported language to another in a single line of code. Additionally, specialized functions like AI_sentiment offer high-quality, state-of-the-art sentiment classification. This granular analysis is crucial for business use cases, particularly in areas like improving service quality based on customer feedback. The key architectural benefit here is that by providing these advanced capabilities directly as managed functions, Cortex entirely eliminates the cost, complexity, and security risk associated with having to move your data out of Snowflake for AI processing. This diagram illustrates how a task-specific Cortex AI function, like translate, processes data. The flow begins when a user submits raw text, often originating from a Snowflake table, using a call to the translate function in SQL or Python. This input is securely passed to the Cortex managed large language model. The Cortex LLM then processes the text internally, performing the translation task. Once completed, the translated text is returned as the output. Finally, this result can be directly stored back into a Snowflake table or used for further analysis. This entire operation, including the complex AI processing, happens within the secure Snowflake environment, highlighting the efficiency and built-in security of Cortex AI functions. The power of Cortex AI functions, such as complete and AI_complete, stems from their ability to access a range of state-of-the-art large language models. These models vary in capability, speed, and cost, allowing you to choose the best fit for your specific task. Snowflake provides access to highly capable models such as Anthropic's Claude 3.5 Sonnet and Mistral Large 2, which are excellent for complex reasoning. Additionally, Snowflake offers its own enterprise-focused LLM, Snowflake Arctic, which is particularly distinguished by its superior performance in tasks like SQL query generation. An innovative aspect of Snowflake's infrastructure is the use of swift KV optimizations within the Arctic models. This specialized technology, developed by Snowflake AI Research, can deliver up to a substantial 75% reduction in inference costs, making large-scale AI deployment more efficient and cost-effective. You can easily interact with these models directly by executing simple SQL statements within any Snowflake worksheet, using functions like snowflake.cortex.translate to perform immediate analysis on your data. For building robust applications and complex data pipelines, developers use the Snowpark Python APIs. These APIs allow you to apply Cortex LLM functions across entire data frame columns efficiently, such as performing sentiment analysis on customer reviews at scale. Finally, for external application integration, the Cortex REST API exposes endpoints for inference and completion. This API enables modern, non-blocking application workflows, supports streaming outputs, and incurs no warehouse charges for the inference itself. This mind map shows the diverse paths to interact with Snowflake Cortex LLMs. The root node represents the LLMs themselves, which are accessible through three main interfaces. First, SQL functions allow direct queries, exemplified by calling the complete function from a standard select statement. Second, the Snowpark Python interface enables programmatic access, notably allowing functions like translate to be applied directly to data frames, optimizing data processing. Third, external applications can use the Cortex REST API, primarily accessing endpoints such as /cortex/inference complete. These interfaces connect to various models, including high-capability ones like Claude 3.5 Sonnet and Mistral Large 2, as well as highly optimized models developed by Snowflake, such as Snowflake Arctic and Llama 3.1 variants. Moving beyond simple functions, Cortex agents represent the next level of intelligent automation within Snowflake. They are sophisticated orchestrators specifically designed to deliver complex and meaningful insights by seamlessly coordinating actions across both structured and unstructured data sources simultaneously. Operationally, a Cortex agent works like a diligent assistant. It first plans the steps required to answer a user's query, then selects and utilizes the necessary tools to execute those planned tasks, and finally synthesizes the collected information to generate a grounded, comprehensive final response. For engaging with traditional structured data, the agent relies heavily on Cortex Analyst as a tool. Cortex Analyst converts natural language questions into precise SQL queries which are then executed against Snowflake tables or semantic views, ensuring accurate data retrieval. When dealing with unstructured content, such as documents, transcripts, or policies, the agent employs Cortex Search Services as its retrieval mechanism. Cortex Search efficiently finds and extracts the most relevant knowledge needed to ground the agent's answers. Furthermore, agents offer extensibility through custom tools, which are defined using standard Snowflake user-defined functions or stored procedures. This allows developers to integrate bespoke business logic or connect the agent to external backend systems. This powerful technology is deployed conveniently through the agent's API, enabling seamless integration into enterprise collaboration environments like Microsoft Teams and Microsoft 365 Copilot, providing natural language data access where decisions are made. This diagram shows the orchestration process performed by a Cortex agent. It starts when a user presents a complex natural language query. The Cortex agent orchestrator receives the query and decides which tools are needed to find the answer. If structured data is required, the agent routes the request to Cortex Analyst, which generates the necessary SQL against structured data like semantic views. If unstructured data is needed, the request goes to Cortex Search, which retrieves documents and context from the search service. The structured SQL results and the unstructured retrieved context are returned to the orchestrator. Finally, the agent synthesizes all this information using an LLM to generate the grounded and comprehensive final answer for the user. Cortex Search is a fundamental AI feature in Snowflake, enabling low latency and high-quality fuzzy search capabilities directly over your vast text data. This is particularly vital when dealing with large volumes of unstructured content like documents, transcripts, or knowledge bases. The primary application of Cortex Search is powering Retrieval Augmented Generation, or RAG, applications. In this context, Cortex Search functions as the dedicated retrieval engine, ensuring that the large language model receives timely, contextual, and proprietary data to generate answers that are accurately grounded in your enterprise knowledge. A key strength is its hybrid retrieval approach, which intelligently combines semantic vector search with traditional keyword search. This built-in, ensemble method eliminates the need for manual parameter tuning or infrastructure maintenance, allowing developers to focus purely on the application logic. When you define a Cortex Search service, Snowflake automatically manages the entire back-end complexity. This includes all necessary data transformations, generating vector embeddings on your behalf, and creating a highly optimized index ready for low-latency serving. The costs for running Cortex Search are based on a managed, multi-tenant serving compute model, which is separate from your standard virtual warehouses. You are charged based on the amount of uncompressed indexed data, including the computed vector embeddings, consumed per month. Developers can easily interact with the service using familiar interfaces, directly via SQL functions like search_preview, through the Snowflake Python APIs, or by accessing the specific REST API endpoint provided for query retrieval. This diagram illustrates the Retrieval Augmented Generation, or RAG, architecture enabled by Cortex Search. The process begins with the user prompt, which is sent to two components simultaneously. First, it goes to the Cortex Search service query, which performs a semantic search over indexed unstructured data to retrieve the most relevant context or documents. Second, the initial prompt, along with the newly retrieved context, is combined into a comprehensive package labeled context and prompt. This enhanced input is then passed to the Cortex LLM via a Cortex LLM function, typically complete. The LLM uses this high-quality, relevant context to generate a precise, factual, and grounded answer, ensuring the response is based on your proprietary data. Governance is paramount in Snowflake, and security for Cortex LLM functions begins with the Snowflake.cortex_user database role. This role grants the essential privileges required to call the Cortex AI functions. By default configuration, the Cortex_user role is automatically included in the public role. This means that, out of the box, all users in your account have access to Cortex LLM capabilities, providing frictionless adoption. However, administrators can revoke this public access and grant the role explicitly to specific roles for tighter control. To manage which specific models users can interact with, Snowflake provides flexible controls. Administrators can use an account-level allow list to set broad restrictions, or they can apply granular role-based access control to model objects listed in Snowflake.models for fine-grained access management. Regional availability is handled by configuring cross-region inference using the Cortex_enabled_cross_region parameter. This ensures that if a highly capable model is not hosted in your local region, the request can be securely processed in an alternative, supported region. It is important to understand the billing model. LLM functions incur charges based on token consumption. This includes both input tokens sent in the prompt and output tokens generated in the completion, ensuring transparent usage tracking. Finally, for auditing and optimization, Snowflake provides dedicated views in the snowflake.account_usage schema. These views, such as Cortex_functions_usage_history, allow you to track the exact token and credit consumption for every LLM function call made across your account. This diagram illustrates the governance pipeline for Snowflake Cortex LLMs. First, any user initiating a Cortex LLM function call must possess the necessary privileges, typically granted through the Snowflake.Cortex_user database role. The function call then proceeds to a model access check, where access is verified against configured role-based access control and account-level allow lists. Upon passing, the request is executed as LLM inference. This process generates token consumption data, which is the basis for usage cost. Critically, this consumption data too is logged into the Snowflake.account_usage views, providing detailed transparency for administrative monitoring and auditing of all AI activities and associated costs.
Thank you for watching this module. I hope you enjoyed the session. Please continue, Harry. You will certainly learn a lot more.